Good morning, students. Now we can see in inverse the transform. So this is Cauchy integration residue method. Here x of z is this a transform of x of n, then x of n is equal to 1 by 2 pi j x of contour integral x of z z power n minus 1 dz. So this is inverse z transform formula. Here x of z z power n minus 1 can be renamed as is g of z. Okay, now we are going to find g of z is nothing but sum of residues of g of z corresponding to the poles of g of z. Okay, now residue R is residue at pole z equal to a is equal to z minus a into z of z, the pole z equal to a. So z of is g of z x of z z power n minus 1 already told you. If single pole, no problem. If the multiple pole is present, we have used this method, that is the residue at pole z equal to a is equal to d m minus 1 divided by d z m minus 1 within a flower bracket z minus a to the power m. This is for multiple poles divided by m minus 1 factorial g of z. At we have to get the residues z equal to a. Now we can see the problem. The first problem, x of z equal to 10z divided by z minus 1 z minus 2. Now you write down the z of g of z equal to x of z z power n minus 1. So x of z is given. X of z 10z divided by z minus 1 z minus 2 z power n minus 1. Okay, so now what will happen here, z power n you will get z inverse, this is z inverse get cancelled, this is z inverse get cancelled. So 10 z power n divided by the remaining term will get it. So now if you look at this, we have how many poles? 2 poles in the from the denominator. One is z equal to 1, the other pole is z equal to 2. Now we have to find the residue of z of g of z. At first you consider at z equal to 1. At z equal to 1, so z minus 1, 10 power z 10 z power n divided by z minus 1 z minus 2. So what is the pole at z equal to 1? So this one get cancelled. Okay, now you substitute wherever z is present 1, you will get the answer. Similarly, we have to find, so this is for at z equal to 1 pole. Then you have to find z equal to 2, that is this part. Now you add these two, minus 10 plus 10 the whole 2 to power n. Okay, so this is the answer of the problem. Okay, so we have to find residues for each and every pole, then you add it, that will be the final answer. The next problem, x of z equal to z squared plus z divided by z minus 1 the whole squared. So we have to use residue method. So what is the formula? G of z is equal to x of z z power n minus 1. So x of z is the problem. You substitute it. This you will get it here. Then multiplied with the z power n minus 1. Okay. So this you from these two z take it as a common, z and z inverse get cancelled, this is the remaining term. Now you take inside, you will get this one. What is the residue? Residue is equal to 1, but we have here multiple poles. So multiple poles we see, already we saw the formula in the first slide. Okay, so what is the order of the pole? 2. Now you come to here, the formula is written. Okay, r equal to z equal to a, that is residue at z equal to a equal d power m minus 1 dz m minus 1. What is the order? M is 2. Okay, 2 minus 1 1, 2 minus 1 1, z minus what is a? As per the problem a is 1, 2 minus 1 1 factorial g of z. What is the pole? Z equal to 1. Okay, d by dz, z power, what is g of z? We got it here. Okay, so the g of z is nothing but this part. You substitute it here. Okay, z minus 1 the whole squared divided by this one. G of z is this part. So this z minus 1 the whole square, this get cancelled, the numerator you will get it. Okay, now you substitute z equal to 1 after doing the differentiation part. So what you will get, n plus 1 z power n plus n into z power n minus 1. Now you substitute z equal to 1. So you will get the answer here. So the x of n is equal to 2n plus 1 into u of n. Now the third problem, using residue method. Here also the multiple pole is given. So you take the g of z as 3z minus 1 into z 2 into z minus 1 the whole cube z power n minus 1. Okay, now this z and zn was get cancelled. Okay, you take the z, you will get like this, isn't it? Now what is the order of the pole? 3. Now the same formula you substitute, instead of m you will get like this. So this has to be differentiated by 2 times. First you do the first time, you will get this one. Then you do the second time. Afterwards you substitute z equal to 1. So the final answer will be this one. Okay, this is inverse z transform by using the residue method. Only you have to use the formula. If it is a single pole, it is easy. If it is a multiple pole, using the formula we have to solve it.